Alright, so in this video we'll take a quick look at Boxplots. And in order to create Boxplots, the first thing that we need to do is make sure we're aware of what a 5-number summary is. So what a 5-number summary is going to tell us is going to be the minimum data point, the first quartile, the median, the third quartile, and the max. So one of the ways to think about quartiles is basically quartile 1 is going to be the middle of the first half of the data, and then quartile 3 will be the middle of the upper half of the data. So, quick example here. Let's say that this is some data taken about the beginning pulse in a class of 23 students, right? The n equals 23. And so you can see if it's already in order. So there's your minimum of 50 and your maximum of 110. Those are pretty easy to spot. But then if you did the counting thing, right? If you cross off each one as you go, you work your way toward the middle, you'd end up right here for the median. So the median for us is 79. Now, if we wanted to find quartile 1 and quartile 3, you basically pull your same idea from the median, except what you'll end up doing is you start after the median, or before the median. So 80 and 110 would be crossed off. 80 and 110, 108, 81, so on and so forth. And you'd end up at 87 in the middle of the data for the Q3, and then 66 in the middle of the first half of the data for quartile 1. So when you find the quartiles by hand, you actually don't start at the median. You'd work your way from just inside the median and on out. So we take a look at another set of data. The big thing with this one, 70 ends up being the median, even though there's a even number of data points, right? But I think everyone's pretty well aware. Here, if we started counting in, the middle would be between this 70 and this 70. Well, that's pretty easy to do in your head. That just means that the middle of the data is 70. And then if you start doing the quartiles, you end up between 64 right here, between 64 and 65. And so you take the average of 64 and 65, excuse me, and that's where that 64.5. And to find the third quartile, you'd end up between 77 and 76, which is where that 77.5 comes from. So even though they're not in the data set, you start on either side of the median and then work your way back to find the middle half of the data. Right? So outliers could also be an important part of Boxplots, so we want to make sure that we're comfortable finding those. I know up to this point in the class, we basically just said it looks like there might be, there appear to be outliers, there appear to be no outliers, but this is actually kind of an algorithm to go ahead and determine yes or no, there is an outlier. So if you go through this process, there's no guessing. So the first thing we want to do is find the interquartile range, which is just Q3 minus Q1. And then what you're going to notice, you're basically going to take, so you got your data, and then all of a sudden there's Q1. And then we got more of the data, and you have Q3. And then you got the last part of the data. Well, what this 1.5 is going to do, it's basically going to take this IQR, this range right here, and it's going to expand it out just a little bit more. So most of the time you're going to catch pretty much all of your data, but every once in a while there's going to be a point that maybe isn't in there. So if we go back to the previous slide, where Q1 is 64.5 and Q3 is 77.5, the IQR there, you just Q3 minus Q1, so it's similar to a range, except you're essentially finding the range of the quartiles, and then you multiply that by 1.5, and then that's basically going to be your buffer. So you're going to take this 19.5, you're going to subtract it from Q1, so you might call this the lower bound for outliers. And then you do the same thing, but this time we're going to add it to Q3. And this is our upper bound. So for us, anything beyond those two numbers would be an outlier. So you go back and you look at the data set. Well, there's nothing below 45, so there are no outliers below. But here's a 109 that's above. And so we can go ahead and say with certainty now, the statement's no longer there appears to be an outlier, but there is an outlier. So here's how all this stuff plays out. As we start to create these box plots, first thing we need is that 5-number summary, the minimum, the quartile 1, median, quartile 3, and the max. And outliers may or may not come into play with a box plot, and we'll show you that in just a second. So as you create your box plot, or what some of you guys might have seen as a box and whisker plot, right? The minimum is going to be where the whisker starts, and then the quartiles, this is where your IQR is. So one way to think about this is the IQR, the interquartile range, is actually the width of the box in your box and whisker plot, which you might have heard of it called that before. Median is going to be a line at some point, right, somewhere in the box, and then the maximum is going to be at the end of the other whisker. So if we think about this, the middle 50% of the data is going to be inside the box, right? From quarter 1 to quarter 3, that's half of the data. And then you get 25% of the data in each whisker. So we've looked at examples in class where we start messing with the length of the whiskers and length of the boxes. But no matter what happens, the whiskers always contain 25% of the box. And then if you want to think about it this way too, from the start of the box to the median, right? That's also always good. That's always going to be 25%, along with from the median up to the third quartile. Right, this is always going to be 25% of the data. So how do outliers play into this? Well, sometimes you might end up with what's called a modified box plot. So it's going to show you if there are outliers present. And this time the whisker no longer goes all the way to the minimum or the max, but it's going to go to the largest or smallest value from your data set that's not an outlier. So if I could flip all the way back. Here, if we were to create a box and whisker plot with this data from the pulse rates at the end of class, since 109 is an outlier, this would end up showing up in the modified box plot as basically a dot, and your whisker would stop right there at 87. It's not going to stop at the bound. That's a common mistake that a lot of people make. It doesn't stop at 97. It's going to stop at a data point that's from your data set. So what one of those would look like, all of a sudden, here are these outliers, right? So the minimum and maximum are no longer the end of the whiskers, so they're going to be an actual point. But the big thing to realize here is that the whiskers are going to end at observations within the data set, not at the bounds. Right? And then one other thing to think about with box and whisker plots, so let's say we did this memory study on the effect of caffeine and memory. Right? Might be of interest to some of us as high school students as we study. Right? Got to stay up the night before and cram for a test. Well, nobody listening to this would ever do that, but sometimes people do, believe it or not. And so people drink caffeine-free cola, regular cola, and then some drink a mixture of the two. So some data was collected. Right? One thing to kind of point out, right? N equals 15, so there's 15 people in each group. And what you see, you get kind of this big list of numbers thrown at you. So one of the things we can look at, the fact that we have 5-number summaries, this lends itself very, very well to a box plot. We don't have the actual data in this particular study, so it makes it a little bit difficult to create any other kind of graph. We can't create histograms or ogives or stem and leaf plots because we don't have those 15 points of data. So what we can do is go ahead and create a box and whisker plot. Now, this first one, if you look at it, all of a sudden, here's this outlier sitting way out here. And what we need to recognize is this is actually, we're looking at a modified box plot. One thing that we could point out, and you're going to have to take advantage of this, we don't necessarily know where that whisker is going to end, but you're going to have to believe me that apparently right here is the last data point. And then, so the question that I guess maybe we would ask is, how could you figure out that outlier? And the reason we could is because we can actually go ahead, I believe it's the high caffeine, because we have Q1 and Q3, that's really all we need to determine if there are outliers there. So we can actually do our 1.5 IQR rule, figure out if there's outliers, and it turns out in this particular case, 10 is an outlier. So just to kind of show you what that looks like in a box plot, you'll have to believe me that, apparently 16 was the first observation, not an outlier in this data set, but um, it kind of gives you a feel for if we wanted to start comparing these things, maybe what our best bet was in terms of whether or not to caffeinate up before we study for tests. Um, so you can see the median for low and none is the same. It looks like low had the highest max, but we start thinking about this, it looks like no caffeine. If I start looking beyond just a measure of center or a maximum value, it looks like right here with a none, the IQR is smaller, which if we think about that, that's basically telling us, hey, I think there's less variability, so it looks like the data points are a lot closer together for none. So maybe our most consistent results are happening when there's no caffeine in the body. So depending upon how we want to interpret this, what do we want to talk about measure of spread, measure of center? We can then make our determination. And just so we can see it too, there's what it look like is just a regular box plot as opposed to modified. And you get a little bit better feel for what that outlier kind of does to the whisker. So there it is with box plots and modified box plots, and then also taking a look at some parallel box plots.